I've relayed this message to one of my friends. I was just going over the importance of learning how to think, and apparently academics have lost that ability. So here's something that I wanted to share with my viewers. I write here, you will discover something. It might be big or small. It might have already happened. This is why it is imperative that you write everything down. Written language is one thing that separates us from the animals. A few tips for you to help you. I don't think like a regular academic. It's my strongest suit. And I told him, he already knows that. Number one, consider everything you read to be complete bullshit. This is by far the most important rule of thumb for any scientist, yet these days they are skeptical only about what the establishment disagrees with. This is really, really bad and breeds incompetence and confusion. Now, this incompetence and confusion is apparent because they believe that matter exists which cannot be seen, called dark matter. That is the most incompetent idea I've ever heard. But the reason why they accept it is because they only consider what they think to be correct, and everybody else is, nonsense. But if they were skeptical about their own ideas, maybe they might get somewhere. Number two, always look for contrarian opinions and alternative explanations. That is basically self-explanatory. If you're not looking for opinions where they differ from what the establishment considers correct, or you're not looking for alternatives to ideas which clearly don't make any sense, like space-time warping to explain gravity, which that just doesn't make any sense at all, then you're not going to get anywhere. You have to look for different ideas concerning the problem. That's number two. Number three, always look for the simplest explanation. If something is really complex or full of lingo, it's probably bullshit. Just check out the Higgs boson page on Wikipedia and you'll see what I mean. The Higgs boson page, has hundreds of references. It's highly sourced, and it's absolute trash. There is no Higgs boson. It's political propaganda. They only had to claim its discovery because they wanted to build the LHC bigger and save everybody's jobs. But that's a whole nother story in itself. Number four, if you find an explanation for something and it appears to make sense, then there's probably something correct about it. Now, I didn't say everything is correct about the explanation, but there's probably something correct about it, meaning there's something correct about it. Like, it's not a complete thing. There's a little part in there that makes sense, but you have to learn how to find that part, where that part is. Number five, if you find an explanation for something and it appears to be bullshit, then there's probably something wrong about it. Same thing, only in the reverse. If something appears to be bullshit, then there's probably something wrong about it. Yeah, of course. There's probably a little tiny bit of something in there that needs to be corrected, and that's what your intuition is for. I wrote that here. 4 and 5, I'm talking about intuition. Overeducated people don't have scientific intuition. It gets erased out of them in graduate school. Only people with limited scientific educations have scientific intuition. This means people that are fresh out of their bachelorette program in college and schools. But once you go into graduate school, man, you can kiss that intuition goodbye, because they mold you like a factory. They make everybody one size fits all. Everybody thinks the same. Everybody looks at the problems the same way. There's no creativity. It's basically stamped out of you in graduate school. Graduate school is a huge issue in astronomy. No astronomer should ever need to go to graduate school. Graduate school should be for technical kind of things, like how to build a telescope or, things like that. Not interpretations of the stars. That's completely misplaced. And finally, the last one, number 6, think laterally. Remember, if there's a problem, there are probably multiple ways to solve it. This is very important as well. If you have an issue where you're confused about how something works, there are probably multiple ways of getting to the bottom of it. That's how discoveries are made. For instance, if you wanted to measure the volume of an oddly shaped object, would you take a ruler to it? That would take all day and would be completely impossible. But there was a man that figured out that if you dropped that item into a thing of water, it would displace the water equal to the amount of volume inside that object. Basically, he figured out another way to solve measuring the volume of an oddly shaped object, such as a king's crown. So here you go. Here's 6 basic things that I want my listeners and readers to look at. These are preliminary, but basically these are the kinds of things that a lot of scientists, they don't learn this kind of stuff in school. They get told to do math equations, they get told to accept everything they're told and not ask questions. But that's not how we progress. You have to always ask questions, no matter who says it, no matter what authority it comes from, so to speak, no matter how long we've believed it. You always have to question reality. Alright, I think that sums everything up for this talk.